All right, here are solutions to perfect problem 5 for Math 211. What you're doing in this problem is really just one multiplication problem and one division problem. Unfortunately, you're going to do that 3 different ways for multiplication, 2 different ways for division. And I chose these horrible numbers. In hindsight, I wish I had chosen smaller numbers, but I guess that ship has sailed. So we're multiplying together 1,742 and 5,061. And we're asked to do this using the standard algorithm. Using the standard algorithm, basically you take one digit from one of your factors and multiply it by the other factor. So 1 times 2, 1 times 2 is 2, 1 times 4 is 4, 1 times 7 is 7, 1 times 1 is 1. Fine. And then you focus on this 6, but really you have to remember that this 6 represents 60. So to account for that fact, you throw a 0 here, and 6 times 2 is 12, which maybe I write a 2 and carry a 1. 6 times 4 is 24, plus 1 more gives me 25. So I'll write a 5 and carry a 2. 7 times 6 is 42, plus 2 more gives me 44. So I'll write a 4 and carry a 4. And 6 times 1 is 6, plus 4 more gives me 10. So I'll write that 10 here. Really, I'll write a 0, carry a 1, which I then drop down here. And then repeat. With 0, you could put 2 zeros in for placeholders to point out that this 0 represents 0 hundredths. But after you did that, then you take 0 and multiply it by this number, which is just 0, and all of that would just leave you with the 0 here, which I'm not even going to bother to write. Then we'll move on here. Instead of 5 times this number, it's really 5,000 times that number, so I have to put in 3 zeros kind of as placeholders, I guess. And 5 times 2 is 10, so I'll write a 0, carry a 1. 5 times 4 is 20, plus the 1 that I carried gives me 21, so I'll write a 1 and carry a 2. 5 times 7 is 35, plus 2 more gives me 37. So I'll write a 7 and carry a 3. 5 times 1 is 5, plus 3 more gives me 8. So what I now do, the algorithm tells me that add up all these partial sums. So 2 plus 0 is 2. 4 plus 2 plus 0 is 6. 7 and 5 gives me 12. So I'll write a 2 and carry a 1, I don't know, there. 1 plus 2 plus 4 gives me 6. 0 and 1 is 1. 1 and 7 is 8. And 8. So what I get is that this product is equal to 8,816,262. And then repeat. So I'm going to do this again. Now I have this number 1,742, and I'm multiplying it by 5,061. Except now instead of using the standard method, I'm using the intermediate algorithm. And the idea with the intermediate algorithm is more partial sums appear. So I'm going to do 1 times 2 and get that that's just 2. And then 1 times 40. Well, 1 times 40 would be 40, so I'm going to write the entire 40 down here. And 1 times 700 is 700, which I'm going to write down here. And 1 times 1,000 is 1,000, so I'm going to write that down here. And then it's not 6 times 2, it's 60 times 2. And 60 times 2 is 120, so I'm going to write that down here. And 60 times 40, well, 6 times 4 is 24, with the 2 zeros that I'll tack on will leave me with the number 2,400. And then 60 times 700, I'm going to have 3 zeros as placeholders, I guess, and 6 times 7 is 42. And then 60 times 1,000, I'll have 4 zeros. And then 6 times 1 is 6. And then I could multiply 0 times all these numbers, but since they're all 0, I'm not going to bother. And then 5,000 times 2 is 10,000. 5,000 times 40, well, let's see, I have 4 zeros in here, and 5 times 4 is 20. So I'm going to write the number 20, and then I'm going to tack on 4 zeros. 5,000 times 700, well, now I have 1, 2, 3, 4, 5 zeros, and 5 times 7 is 35. So I want 5 zeros with a 35 out in front. And then finally, 5,000 times 1,000 is 5 million, or 5 times 1 is 5, and I have 6 zeros tacked on. So I get 5, and then these 6 zeros. Now my task is to add up this mess. Well, I got a 2 and a whole bunch of zeros, that just sums to 2. A 4, a 2, and a bunch of zeros, that sums to 6. A 7, a 0, a 1, and a 4, that sums to 12. So I'll write a 2 here and carry a 1 up into this next column. The 1 that I carried, maybe I'll write that somewhere, I don't know, here. Sure. 1, 2, 3, 4, 5, 6 is what I get in this column. Nothing carries. 4 plus 6 is 10, plus 1 more is 11. So I'll write a 1 and carry a 1 into this column. 2 and 5 is 7, plus 1 more is 8. And 3 and 5 is 8. And hopefully, I get the exact same answer, 8,816,262. Awesome. But you're not out of the woods yet, because you now have to do the lattice method. The idea for the lattice method is to take one of your numbers, like 1,742, and write it horizontally. And then take your other number, 5,061, and write it vertically. Sort of create this grid. Which is a little bit challenging on a computer, but hopefully this is legible. And so I have this 4x4 grid here. And the idea is to put in some diagonals, so maybe I want another color. Maybe I'll go back to blue, because I'm later going to add on these diagonals here. Which this is a little bit challenging to do as well on a computer, but maybe you're sick of hearing my complaining, so I'll stop. Maybe. Now I'm going to go through and fill in all the boxes. So 5 times 2 is 10, but I'm not going to write the number 10. I'm going to put a 1 up here and a 0 here. 10. 2 times 0 is 0, so I'll write that like this. 2 times 6 is 12, so I'll write that like that. 2 times 1 is 2, so I'll write that like that. 4 times 5 is 20. 4 times 0 is 0. 4 times 6 is 24. 4 times 1 is 4. 7 times 5 is 35. 7 times 0 is 0. 7 times 6 is 42. And 7 times 1 is 7. 5 times 1 is 5. 0 times 1 is 0. 6 times 1 is 6. And 1 times 1 is 1. Now that I've filled out my lattice, my grid here, I'm going to add on the diagonals. So it might even help to have these diagonals extended a little bit, although that might make it even harder to read. 2 is the only thing I have on this diagonal, so I'll write it right here. 2 plus 0 plus 4 is 6. 1 plus 4 plus 7 is 12. So what I'm going to do is write a 2 here and carry a 1 up here somewhere. 1 plus 0 plus 0 plus 2 plus 2 plus 1 gives me 6. 1 plus 4 plus 6 is 11, so I'll write a 1 and carry a 1. 1 plus 2 plus 5 is 8. 3 and 5 is 8. And then you have this last 0 up here, so I get 8,816,262, the same answer that I got using my other methods. And we're still not done, because now what you are asked to do is to check your answer by dividing. So it should be the case that when I take 5,061 and divide that into 8,816,262, I should get as my answer 1,742. Let's see if it works. Well, what I got to do is stare at this 5061 number and say, well, it can't go into 8 or 88 or 881, but it could go into 8,816. It could go in one time. And 1 times 5061, I could then subtract. 6 minus 1 is just 5. 1 minus 6, I can't do it, but 11 minus 6 is 5. So that 8 changes into a 7. 7 minus 0 is just 7. 8 minus 5 is 3. Get something like this. And now you bring down this 2. So now what I got to do is stare at this thing and say, how many times does 5,061 go into 37,552? Well, I don't know that you know that off the top of your head, so you do one of two things. Either you say this is close to 5,000, and 7 5,000s is close to 35,000. I bet I could get 7 out of this. Or you cheat. And you say, well, my answer should be 1,742. So this should be a 7 right here. 7 times 50, 61. Well, 7 times 1 is just 7. 7 times 6 is 42. So I'll write a 2 and carry a 4. 7 times 0 is 0, but I had that 4 that was carried. And 7 times 5 is 35. So I get here. And now I subtract. 12 minus 7 is 5. Changing that into a 12 meant I changed this into a 4. 4 minus 2 is 2. 5 minus 4 is 1. 7 minus 5 is 2. And so I get 2,125. And now I drop down another digit, this 6 right here. 21,256. How many times does 5,061 go into that? Well, again, you can either check or you can say it's close to 5,000, so there's about 4 of them in here. 4 of them would be exactly 20,000. Let's try 4 out. 4 times 1 is 4. 4 times 6 is 24, so you carry a 2. But 4 times 0 is 0, so 0 plus the 2 gives me the 2. And 4 times 5 is 20. And now I subtract. 6 minus 4 is 2, 5 minus 4 is 1, 2 minus 2 is 0, 1 minus 0 is 1. Alright, I'm good. I was afraid I messed something up, but I think I'm good because I think when I take this last digit and drop it down here to get this 2, things will work out okay. How many 5,000s go into roughly 10,000? Well, I guess probably about 2. Let's see if that works out. 2 times 50, 61. Well, 2 times 1 is 2. 2 times 6 is 12, so I'll write a 2, carry a 1. 2 times 0 is 0, but the 1 I carried gives me a 1 here. 2 times 5 is 10. I subtract. I get no remainder. I'm very happy because getting no remainder, and this is my quotient, checks these answers. And you're still not done. You're going to do this one more time. You're going to do it with the scaffolding method. So the idea with the scaffolding method is similar to this algorithm, but now I'm going to start out with the entire, where should I write this? Maybe here. 50, 61, and I want to divide that into, no way that's going to fit there. Maybe I do it over here. Where do I have room? There's got to be room on this thing somewhere. Let's do it down here. Fine. 50, 61, and I want to divide that into 8 million. God, I wish I had given you an easier problem. 262. The way we're going to do it with the scaffolding method is we're going to take out chunks. And what do you mean by chunks? Well, how many times roughly does 5,000 go into 8 million? I don't know. I can certainly get 1,000 out of it, because 1,000 of this number would be this number with 3 zeros tacked onto it. So I get 5061 with 3 zeros after it. And if I now subtract 11 minus 6 is 5, I get that I still have 3,755,262 to go. So where do you go from here? Well, you're trying to find another round number, another chunk of 5,061s to take out. This is a little bit tricky because we know what the answer is, right? We know there's 700 of them in there. But maybe you don't know that, so I don't know. Maybe you would choose to put something like 500 here because you like 5s because they're easy to multiply by. Well, if I have 500, I put these 2 zeros here and then take 5 and multiply it by this number. 5 times 1 is 5. 5 times 6 is 30. So 0 and carry a 3. 5 times 0 is 0, but here's the 3 I carried, and 5 times 5 is 25. So to be clear, the number I put here is pretty arbitrary. I'm looking for any round number that I know I can subtract that many groups of 5061 from what I had left over here. So you might have put 700 here, or 200, or 100. It's totally up to you. Now I'll subtract. And so I get, what, 1, 2, 2, 5. That was a bad idea. I tried to subtract left to right, which is never smart. Let's go the other way. 2 minus 0 is 2. 6 minus 0 is 6. 12 minus 5 is 7. I had to borrow 1 here, so that's a 4. 2, 2, 1. And now I stare at this thing, and I'm like, well, there's more I can take out. Maybe 200 would be a good idea, because 200 of these things are roughly 1 million, and I have over 1 million. So I take this number and I multiply it by 200, which means tack on these 2 zeros, and then multiply this number by 2, which I think I've done before. I think I've done that over here. I think it's 10122. And then I subtract again. And I'm kind of low on room, so what I'm going to do is cheat and move this guy up here. When I subtract, I get the 2, the 6, 7 minus 2 is 5, 4 minus 2 is 2, 2 minus 1 is 1, 2 minus 0 is 2, and so I'm here. And then you say, all right, how many 5061s can go into this number? Maybe I'll keep going, 5061. I don't know, not 100, maybe, all right, maybe 40, sure. You might not have chosen 40 here. Maybe you chose, okay, let's do that. Let's choose 20 instead of 40. Why would you choose 20 instead of 40? Well, I already know that 200 times 5061 is this number. So 20 times 5061 will be this number with one less zero at the end. I'd get 1, 0, 1, 2, 2, 0. And then I can subtract. 2 minus 0 is 2. 6 minus 2 is 4. 5 minus 2 is 3. 2 minus 1 is 1. 1 minus 0 is 1. 2 minus 1 is 1. And now you notice, hey, I could take out another 20 from that because I know that 20 is 1, 0, 1, 2, 2, 0. So let's subtract. 2 minus 0, 2. 4 minus 2 is 2. 3 minus 2 is 1. 0, 1. So I have this many left. You're like, hey, I recognize that number. That's exactly two of these things. 1, 0, 1, 2, 2. I'm left with 0. So now what I have to do is sum up all these numbers. 100 plus 500 plus 200 plus 20 plus 20 plus 2. Sorry, 1,000. So I get 1,742, which is exactly what I got here, which is what I was supposed to get. God, that was miserable. That's the end of this.